Ever wondered how your eyes work, allowing you to see the world around you? Well, you're in the right place. In this countdown, we're diving into the incredible world of vision, starting with the basics and then venturing into the fascinating details. From the cornea to the brain, we'll explore the complexity and the brilliance of the human eye. So sit back, relax, and let's embark on this enlightening journey together. Prepare to be amazed by the complexity and brilliance of the human eye. Starting at number 10, let's talk about the basic structure of the eye. The eye is an intricate organ, composed of various parts that all work together to create the images we see. First up, we have the cornea. This is the eye's outermost layer. It's a clear shield that protects the eye and begins the process of directing light into the eye. Next is the iris, which you might recognize as the colorful part of the eye. It works like a camera shutter, adjusting the size of the pupil to control the amount of light that enters the eye. Behind the iris is the lens, which fine-tunes the focus of light onto the retina, the innermost layer of the eye. The retina acts like a screen, capturing light and turning it into electrical signals. Each part of the eye plays a crucial role in the process of vision. At number 9, we delve into the cornea, the eye's outermost layer. Imagine the cornea as the eye's personal window to the world. It's a clear shield, guarding the inner eye from harmful elements, but it's more than just a protector. The cornea has a pivotal role in your vision. It does the heavy lifting in focusing light. When light hits your eye, the cornea is the first to greet it, bending or refracting the light rays to focus them onto the lens. This is a critical step in the process of vision. Without the cornea's refraction, the light wouldn't hit the right spot on the retina, and the image you see would be blurry. It's like the cornea is the director of the light show happening in your eyes, ensuring every light particle lands just where it should. So let's give the cornea the credit it deserves. The cornea is the eye's first line of defense and plays a key role in vision. Next up, at number 8, is the lens. The lens is an integral part of the eye, a clear piece of tissue situated behind the iris and the pupil. It's much like a camera lens, and its primary function is to focus light onto the retina, the light-sensitive tissue at the back of the eye. The lens achieves this by changing its shape, a process called accommodation. When the eye looks at an object that's close, the lens becomes rounder to increase the bending of light. Conversely, when the eye focuses on a distant object, the lens flattens, reducing the light's refraction. The lens is also responsible for a significant portion of the eye's total optical power. It can adjust from about 20 to 34 diopters depending on its shape and flexibility. This flexibility diminishes with age, which can lead to conditions like presbyopia, where the eye loses its ability to focus on near objects. Without the lens, we wouldn't be able to see clearly. Number 7 is the iris, the colored part of the eye. This vibrant circle surrounding the pupil isn't just there to make your eyes look pretty. It plays a pivotal role in the way we see the world around us. The iris is a group of muscles that expand and contract to control the size of the pupil, which in turn controls the amount of light that enters the eye. In bright light, the iris contracts, making the pupil smaller and letting in less light. On the flip side, in low light, the iris expands, making the pupil larger and allowing more light in. This delicate balance allows us to see clearly in various lighting conditions. Think of the iris as a sort of curtain for your eye. It opens and closes to adjust the light, much like a camera shutter. This intricate dance of light and dark is happening right now in your own eyes. The iris is like a camera shutter, controlling the light that enters our eyes. At number 6, we have the retina. This complex and vital part of the eye plays the role of the protagonist in the narrative of sight. Imagine a theater where the play of light and shadow unfolds. The retina, a thin layer lining the back of the eye, is that theater. It's here that the magic of vision truly happens. Light enters the eye, passes through the lens, and lands on the retina. This light, which can be anything from the radiant hues of a sunset to the words on this screen, is then converted into electrical signals. These signals are like a secret code, a language that the brain is adept at interpreting. Just think about it. Every image that we see, every color, every movement, every detail, is perceived because of this amazing process. The retina is like an artist, painting pictures in our mind with the brush of light. The retina is the eye's powerhouse, translating light into images. Halfway through our countdown at number 5 is the optic nerve. A crucial player in our vision process, the optic nerve takes on the pivotal role of messenger. It's not enough for our eyes to just capture the world around us, someone has to interpret the message. And that's where our brain comes in. Imagine the optic nerve as the high-speed broadband of the visual system. It's a bundle of over 1 million nerve fibers, each one carrying electrical signals from the retina, the eye's light-sensing layer, to the brain's vision centers. This is how we see the world in all its vibrant glory. The optic nerve doesn't merely transmit a static image, it conveys the depth, motion, color, and contrast in every scene. It's the pathway that allows us to recognize faces, read, and even catch a ball. In essence, the optic nerve is our personal live streaming service, delivering a constant feed of visual data to the brain for interpretation. The optic nerve is our eye's connection to the brain. Coming in at number 4 is the pupil. This small and seemingly simple part of the eye holds a world of complexity. The pupil is like a camera aperture, adjusting its size in response to the amount of light in the environment. In bright light, the pupil constricts, reducing the amount of light entering the eye. Conversely, in low light conditions, the pupil dilates, allowing more light to enter and enabling us to see. But that's not all. The pupil also adjusts its size when we focus on objects at various distances, a process known as accommodation. When we focus on distant objects, the pupil constricts, and when we look at close objects, it dilates. This function is crucial for creating clear, sharp images. So, the next time you gaze into someone's eyes, remember that the tiny black dot you see is working hard, constantly adjusting to light and focus. The pupil is the gateway for light entering the eye. At number 3, we have the eye muscles. These tiny yet powerful muscles are the unsung heroes of our visual system. They're like the puppeteers pulling the strings behind the scenes, guiding and controlling the movements of our eyes. 6 muscles in particular work in harmony to rotate the eye in all directions, up, down, left, right, and even diagonally. But their role is not just about movement. They're also essential in maintaining focus. When we look at something close, these muscles contract to thicken the lens, increasing its refractive power. As we shift our gaze to something farther away, the muscles relax, thinning the lens. This constant adjustment is known as accommodation. So whether you're reading a book or watching a bird soar high in the sky, remember, it's the eye muscles working tirelessly that allow you to follow along. The eye muscles keep our eyes moving and focused. Just missing the top spot at number 2 are the tear glands. These behind-the-scenes heroes play a crucial role in maintaining the health and comfort of our eyes. Tear glands, or lacrimal glands, are located in the upper outer region of our eyes. They produce a fluid rich in proteins, water, and oils. This fluid, known as tears, serves a dual role. Firstly, tears act as a lubricant, ensuring that our eyes remain moist and comfortable. Imagine running a machine without oil, or a car without coolant. The result would be disastrous. Similarly, our eyes need tears for smooth operation. Secondly, tears help clean our eyes. Every blink of the eyelid spreads tears across the cornea, washing away dust or debris that may have settled there. This protective layer of tears acts as a first line of defense against eye infections and irritants. In essence, tear glands are like the unsung maintenance crew of our eyes. Tear glands keep our eyes healthy and comfortable. Finally, at number 1 is the brain. This remarkable organ is the command center of our body. It's here that the magic truly happens. The brain receives signals from the eyes through the optic nerve. These signals are not images, but rather a variety of information about light, color, and motion. The brain's visual cortex takes up this information, interpreting and assembling it into an image that we recognize and understand. It's like a master artist taking different pieces of information and crafting them into a cohesive whole. This process is so seamless and instantaneous that we're not even aware it's happening. Think about it. You're not just seeing a tree, but the brain is interpreting light signals to tell you it's a tree, it's green, it's far away, and it's swaying in the wind. The brain is the final piece of the puzzle, making sense of all the information our eyes provide. This is why it's our number 1 in understanding how the eyes work. And there you have it, the top 10 aspects of how our eyes work. Today we journeyed from the cornea's protective dome to the brain's processing powerhouse, uncovering the intricate operations of the human eye. Every component, from the light-bending lens to the signal-sending optic nerve, plays a pivotal role in our visual experience. And let's not forget the unsung heroes, the tear glands and eye muscles. From the cornea to the brain, our eyes are truly remarkable. Thanks for watching, and keep your eyes open for more fascinating videos.